Alright guys, so today is the last day that we are going to be reviewing prior to the IA, so I really wanted to create this video lesson so that we can kind of break up into separate groups. Hopefully this video lesson will be helpful. This is going to be a much longer video, so please be ready for that. I'm sure you can see by the timestamp in the corner that this is going to be a bit more of a long haul, but hopefully it's helpful. Alright, so we're going to start off with this piece, converting each decimal into a fraction, and I encourage you to try this prior to me doing this. So please pause the video and give this a shot. See how many of these you can do without assistance, and once you're done, come back and watch the video again. So hopefully you were able to do that. A lot of you instinctively see that this is going to start at 1/4, but I want to show you how we get there in case you're not sure. It is in fact 1/4. But the easiest way to get there is to actually say, okay, what does this say? Well, this says it's 25 hundredths. It's 25. So I can actually just write this without the decimal and put it over the next largest place value or next largest unit of 10. So I have 25 over 100. And then I can actually start dividing through. So I say, well, what goes into 25 and 100? Hopefully you see that you can divide both of these by 25 initially, by 25, and then you get that 1/4. But if you didn't see that, you could also say, well, let's divide out of 5. If I divide out of 5, then I get 5/20, because I can take a 5 out of here and a 5 out of 100. And then that I can take another 5 out of and say, okay, well, 1/4 when I factor these down. However you go about doing that, 0.25 is equal to 1/4. Now I can do the same thing here. I can say, well, that's 2 over, well, tenths, hundredths, thousandths. So 2 over 1,000. And then I say, well, can I break this down? Let's see, I can take a 2 out of each of these and I get 1/500. Because I factored a 2 out of both of those. I continue down here and I do the same thing. I get 2525 over 10,000. And I continue from there. So I can divide at least 25s out of that and see what happens, and then I continue from there. For the sake of time, please go ahead and continue. By the way, if you wanted to do that, you can literally say 2525 divided by, and it gives us that. So that's not helpful, but you can say, okay, 2525 divided by, well, it looks like I can at least break 25s out of there, and I get 101 over, what's 10,000 divided by 25? I get 400. And I don't believe I can simplify that any further, so I'm going to leave it there. Again, that's just a strategy by which you can do this. Now, simplifying each fraction. These are actually really simple. 2 over 10 is literally 2 tenths, which is written like that. 3 over 12 can be simplified to be 1/4, which is actually 0.25. And we would continue along in that pattern. Hopefully you see that this is also 25 hundredths, which is written like that. This is 25 thousandths, which means it's 0.025. And then continuing on from there. So let me clear these out really quickly. If you have any questions with any of those, feel free to raise your hand. If you want to go through and do any of these, feel free. And then finally, there's an IA breakdown here, which tells you exactly how many of each type of question we're going to see on there, on the calculator, no calculator on the Fluency. Definitely look through here and see what you can figure out, remembering Unit 1 is what we reviewed yesterday. Unit 2 and Unit 3 are what we are reviewing today. So hopefully that gives you a nice breakdown of what we're looking at. Now let's do the Unit 2 review. So we're going to come in here and we are going to write down our definitions. We're going to proceed from there. Now the base of a number, remember Unit 2 was all about exponentials and the rules for exponentials. So let's look at this. The base is the number being raised to a power. It's also known very simply as the big number. So let's say I have 3 to the 5th power. This is the base. This is the base. The 5 sits on the base. The 5 is the power, or the exponent. The 3 is the base. And the exponent is the number of times the base multiplies by itself. So again, if I come over here and I use that same example, I say 3 to the 5th, then the power or the exponent is that 5, which means if I were to do this, let's just use the same example in expanded form. Definition of expanded form is the exponential multiplication written fully out. So with this example, it'd be 3 times 3 times 3 times 3 times 3, because it's 3 to the 5th, which means I need 5 3's. Now please keep in mind this is times, this is not addition, this is multiplication, which means I would have 3 times 3 is 9, not 6. 3 times 3 times 3 is 27, not 9, so on and so forth. Standard form is the exponent solved through, or assessed. The exponent solved through. So in the case of 3 to the 5th power, I would love to say I know that off the top of my head. We're going to say 3 times 3 times 3 times 3 times 3. That is 243. 243. An exponential form is, well, we'll just say displayed or shown, displayed with a base and exponent. It's displayed with the base and the exponent. So that'd be 3 to the 5th power. That's exponential form. Now square means to the 2nd power. So let's say it's 5 squared. Now, when it says squared, you can remember that it's squared because squares are two-dimensional, therefore it is to the 2nd power. And cubed is to the 3rd power. So that'd be 5 cubed. And you can remember that because cubes are three-dimensional. Square root is the inverse of square, and the cube root, as you hopefully saw, is the inverse of cubed. So the square root of 25 and the square root of 120 25, but not the square root, the cubed root. The cubed root. So let's go through here, do a quick check for understanding. I encourage you to pause the video and see how you do with this. All right, bring it back in. The base of this is 8. The exponent is 3. The base of this is negative 5. The exponent is negative 4. The base of this is negative 4. The exponent is 6. Now, it wants us to evaluate these. So let's go through. Starting off, we have 2 times 2 times 2 times 2. 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. So 2 to the 4th power is 16. 8 times 8 is 64. 4 times 4 times 4 is 16 times 4, which is really 64. Rewrite each in exponent and expanded form. Pause the video, give this a shot. All right, so here you should have gotten 3 times 3 times 3 times 3. That's expanded. 8 times 8 times 8 times 8 times 8. And here, this is kind of a weird one, so be careful with these parentheses. This means negative 4 times negative 4 times negative 4. If there weren't parentheses here, if it were just negative 4 to the 3rd, let me do this in a different color actually, so it's not confusing. So this is different. If this were negative 4 cubed, notice there's no parentheses here. It would have been negative 4 times 4 times 4, which means the answer is always going to be negative. Here, I have to see if it's even or odd. Remember, if it's even, it's positive. And if it's an odd number, it's negative, just because of how it works out. This negative is going to cancel out with this one, but then you still have this one kind of hanging out. So, there we go. Go ahead and rewrite each of those in expanded and exponential form. Pause the video. All right, so here you would have seen 1, 2, 3, 4, 5, 6, 7, 8. So I get 6 to the 8th power. Here I get negative 2. The negatives went with it, so they stay in the parentheses, to the 4th power. And here I have, that's just a number for the question, not in here. I have 2 9s, so I say 9 squared times 12 to the 3rd power. So don't let this confuse you. They need to be the same base. All right, exponent rules. Go ahead and read through the exponent rules. Pause the video, read those, and we'll meet over in the application notes. Okay, here we go. What we need to do now is we need to actually combine some of these things. So here's what we have. If I write all of this down, I see that I'm using this rule here because I'm multiplying exponents with like bases. So I'm going to break everything out. I have a 2, I have a y, and then I have 2 y's over here, and I have 3 y's here. Now when I combine these, I actually need to figure out what exactly I have. Well, I have 1, 2, so I'm going to throw that up here, and then I have 1, 2, 3, 4, 5, 6 y's. 6 y's, because I can literally just add these. I have 1 plus 2 plus 3 is 6, so I can do that. Over here, let's break down what we have. We have 4, we have a 2, I have 2 x's, and I have 2 more x's. So when I break these to, or put these together rather, I get an 8 because of the 4 times 2, then x to the 4th because I have 4 x's here. And the same thing happens when you're dividing exponents over here. I say, okay, well, let's write this out. D, 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 that's 1, 2, 3, 4, 5, 6, Y, Y, Y. And then I have 2d down here. 2 of these cancel out, and I'm left with 4. So I get d to the 4th, y to the 3rd, because there's nothing left for those y's to cancel out with. And if we do the same thing over here, I'm going to divide. I'm going to break these into the pieces that they are. So I have the 12 divided by 4. I have h6 over h. 12 divided by 4 is 3. h6 divided by h1 is going to, oh, that's not a multiplication symbol, is going to be h to the 5 because I'm subtracting. So we're going to go through a little bit of this guided practice, and then you're going to have a lot of time to work on your own, and we're going to reconvene down in scientific notation. But for the guided practice, let's do this. I know that I need to combine these things with addition and multiplication. Now these bases, we have 4 times 3. Those are just numbers. So I'm going to do those in blue. 4 times 3 is 12. And then in red, I have d, and here's how I encourage you to write it. Put the base and then put the exponents you have. Now I'm multiplying, which means I'm adding exponents. I'm only adding the exponents, though. I'm not adding these numbers in blue because they don't have exponents. So I say, well, 12, d negative 6 plus negative 6 is going to be negative 12. I actually get d to the negative 12. And this number is 12. So my final answer is 12, d to the negative 12. Now let's come down here and combine these things. In blue, I'm going to do my numbers. So 2 times 6 is 12. In red, we'll do the b, 4. I'm multiplying, so I say plus negative 2. And then we'll do this last one in green, because why not? C, 5 plus, because I'm multiplying. And there's a little 1 up here. You can't really see it, but there we go. And once I carry that through, I'm going to see that I have 12, b to the 2, c to the 6. And then we come down here and we say, all right, cool. All of these are the same base, so I'm just going to say, okay, 8z, that's a z. Wow, that's a terrible z. Let me rewrite that. 8z plus negative 5 plus 8. So that's pretty much done. I mean, I can simplify the negative 5 plus 8 piece, but I get z plus 3 and I'm done. It seems strange, but that's how you do it. Now the same thing I did up there, I'm going to show you how to do down here. We're going to do one of these together, and then I'm going to kind of let you do your own thing for a bit. I'm going to break these into their own separate pieces. So I have 4 divided by 8. That's one piece. My next common base is the s's. So I have s negative 3 over s6, which I don't actually want to write that way though. I'm going to write as s negative 3 minus 6 because I have a division, which means I'm going to subtract. And then in green, I'm going to say t negative 4 minus 8. So my final answer to this is going to be 1 over 2 because of the 4 over 8. Negative 3 minus 6 is going to be negative 9. So s negative 9 t negative 12. And hopefully you saw that this is kind of sloppy. So what we're going to do is I'm going to erase these. And we're going to rewrite that properly, which is going to be 1 over, well, 2 is on the bottom. S negative 9 becomes S9 when I flip it, S9. And same thing with T, T12, because the negative causes it to flip. So I encourage you to go through a bunch of that, and then we're going to come back together, finish the rest of these, come back down to the scientific notation notes when you're ready. Come back, hopefully that was a good use of your time. here we're going to fill in these notes. A number is said to be written in scientific notation if it is expressed as a multiplication of a value between 1 and 10 multiplied by a power of 10, which is just a fancy way of saying all of this. Sorry, I'll let you finish writing that down. It says power, by the way. As a power. Now, each of these is actually really stinking easy. I'm going to say, how many times does this decimal move? 1, 2, 3, 4, 5, 6. 6. I need to go through a couple steps in my head. Is it between 1 and 10? Yes, great. So I multiply it by 10 to the number of times it moved. So it moved 1, 2, 3, 4, 5, 6. So it's 6 to the power of 6. But it was a small number, not a big number, so it's negative. Okay, I come over to number 2 and I say, okay, I need to get this between 1 and 10. So I go 1, 2, 3, 4, 5, 6. And I get 5.4. Is that between 1 and 10? Yes. Times 10 to the 6th power, because it moved 6 times. So there we go. What about this? It moves 1 time. 6 times 10 to the 1, because it moved once. And then this moves 1, 2, 3. I get 9. That's between 1 and 10. Times 10. It was a small number, so it's negative, and it moved 3 times. So hopefully that is reasonably easy. Go ahead and continue through. Now, once you finish that, pause the video. Once you finish that, we're going to reconvene down at operations with numbers and scientific notation. All right, here we go. Operations with numbers and scientific notation. When we add and subtract, the rules are different than when we multiply and divide. When we add and subtract, the powers must be the same. For multiplication and division, doesn't matter. It does not matter if the powers are the same for multiplication and division. So, the basic steps you go through are we need to rearrange the factors, complete the operation, rewrite in proper scientific notation. So let's actually come down here and do this. So we have write the sum of this and this. Now, we know for adding and subtracting, the powers must be the same. So let's get the powers to be the same. My usual strategy is this. Let me zoom in a little bit. My usual strategy is this. I want to make the bigger power smaller. That's just how I usually do this. It doesn't have to work that way. But I'm going to subtract, and remember, when we subtract, move the decimal right. So I subtracted and moved the decimal to the right. Now I have 45 times 10 to the 5th, because I subtracted 1 here and moved the decimal. So, let me rewrite this a little bit. 45 times 10 to the 5th, and 8.3 times 10 to the 5th. The 10 to the 5ths are the same, so I'm going to bring them down here. And here, I need to add. I'm going to say plus, get 3, That's 3. And I get 53.3. And then I ask myself, okay, great. Is this in scientific notation? It is not yet. Hopefully you saw that. I need to put it between 1 and 10. So I move this one place back. And I see that when I go to the left, add, when I go to the left. So it's 5 plus 1. So the correct answer is 5.33 times 10 to the 6th. Now we come over here. That's the exact same thing you would do for subtraction, by the way, except for that part. Now, multiplying. Don't overthink this. In blue, we'll do that. And then in red, we'll do that. So let's do the blue part first. Well, let's do the red part first. That seems easier. When I multiply numbers that have exponents, I just do that part. So, -4 plus 7 gives me 3. And that part's done. Again, don't overthink this. Now I just say 3.5 times 8.2. 2 times 5 is 10. 6, 7. Put a placeholder. That is 40. Make that a 4 just so I don't clutter my space. 8 times 3 is 24. 28. 28. 28.70. Because I moved the decimal twice. So 28.70, so I get 28.70. That's not in scientific notation, so I move it once. I moved to the left, so I add 1. And my final answer is 2.870 times 10 to the 4th. Again, if you're confused by any of that, please, please, please raise your hand and let me know. With that, you're going to go in and you're going to finish this practice with your partners. If you have any questions, please raise your hand and let me know. Best of luck. Now we're at that last little bit here. The last little bit is going to be about Unit 3. Now, hopefully you already have all of these things, but just as a quick reminder, a square is a number to the second power cube is a number to the third power square root is inverse of a square, and cube root is the inverse of cube. Now, the big ones, irrational numbers. Irrational numbers are never ending, non-repeating, not fractions. Real numbers are pretty much everything except this fancy number called I. You don't need to worry about that this year. Rational numbers. Rational numbers are numbers that terminate, they end, repeat, meaning they're predictable, they terminate, they repeat, or they are fractions. And then we will go through the rest of these as we go along. Please complete your square and cubes. Don't use a calculator. You need to know them at least up to 10 and 15 for the squares. Now, comparing rational numbers. you're going to go to this website, you're going to play around with that, and you're going to go through these examples. We are then going to reconvene down at estimating irrational numbers. Go ahead and pause. All right, now looking here. I need to estimate the square root of 80. What two perfect squares is it between? Well, I go back up to my chart and I find out that it is between the square root of 64 and the square root of 81. Now 64 is 8, 81 is 9, 80, if I were turning this into this, 64, 81, 8, and 9. And I wanted to find 80. 80 looks like it's probably closest to there, because it's way closer to 81 than it is to 64. So my estimate would be, well, 8.0, 8.1, 8.2, 8.3, 8.4, 5, 6, 7, 8, 9. I would say 8.9 is a decent estimate. And let's go check that. My estimate is 8.9. Square root of 80 is 8.94. It's a pretty good estimate. So go ahead and do this one on your own. And then we're going to meet down at the Pythagorean theorem. All right, last but not least, the Pythagorean theorem. Please remember there are two different ways to do this, but always with the exact same formula. A squared plus b squared equals c squared. A squared plus b squared equals c squared. Here, I have the two legs, and I know that because they're the things joined by the right angle right here. So I plug them in for a and b. Squared equals c squared. A squared is 81 plus 144 equals c squared. It gives me 225 equals c squared. Now here's the big thing. I cannot forget to square root that. If I don't, I have this weird triangle where it's 9, 12, and 225. That doesn't make any sense. Here I find out that when I square root 225, square root of 225 is actually 15. So x here is 15. Now the difference here is I know a is 6 squared. B, I have no idea. So I'm going to leave it as b squared. And I know that c is 24 squared, and I know that because it's across from my right angle. Across is c. You can remember that because it is across. That's a box around the c. It's across using that c from the right angle. And I would solve in the exact same way. I would go through, I would subtract, and then go from there. The only other thing to notice here is you can actually turn this into a triangle that is 2 by 3. 1, 2, 3. Oh, my mistake. 2 by 4. So those are a and b. So I can say a squared plus b squared plus c squared and plug in 2 and 4 to get c squared. 4 plus 16, c squared. 20 equals c squared. So the distance of this is the square root of 20. Now I encourage you to go through the exact same things over here. You know how long each leg is. 8 squared plus 6 squared equals c squared.